Hello everyone, welcome to another set of tutorials, this time for Lab 7, kind of walking through the different things we'll be doing as far as like analysis in Excel. So this week we were kind of concerned and interested in this idea of trophic interactions, right? How the presence of a specific predator can impact behavior of prey species and also how energy gets passed along and across different trophic levels. So the two things we kind of, or I guess three things we did in class this week were we collected a bunch of mosquito behavior data, right, in the presence of a predator, right, in the presence of a species which is of a higher trophic level, that being the mosquito fish or Gambusia. We also collected some data regarding the activity of those Gambusia individuals, of a series of Gambusia individuals, as well as their associated mass as well. What we're going to be going through in this tutorial is basically how to go about calculating this chi-square test value. And then also for our fish weight and behavior, we're going to be making a series of different plots. These will be two different histograms each for each of these data series, and then combining them both into a scatter plot with which we'll kind of plot a linear kind of trend line onto. So let's start with our mosquito data. The first thing to kind of note is that I sent out a version of this spreadsheet to you guys right after class, which unfortunately has some kind of like inputted info on there. So I want to make sure that you want to make sure that you guys are using this most recent version of the spreadsheet that I'll be sending out with the link to this video as well. You should be able to tell that because this predator absent value before any kind of editing or modification should say 0 right now, right? The previous version of this actually had numbers filled in already, but we actually want to determine these predator absent values based off of the total observations that we get from our own class dataset. So let's start this chi-square process by filling out the kind of the total predator present data that we get for each of these behaviors across our six groups, right? So this row is just going to be the sum of each of the corresponding individual group data columns, right? So in this case, for the breathing with fish, that would be the sum, right? And then we would just drag this across the three other behaviors to get the sum across the three behaviors. Now, what we can do is we can get the sum of all of these three behaviors, and you'll see that this actually already populates for us what the predator absent behavior value should be. Once we have that done, we can then also drag up to double check that these values are equal. You should always have your predator absent totals for the rows be equal, right? So 1061 and 1061 in this case specifically. And the last thing we want to do is the sum across both the predator absent and the predator present behavior values. So we're going to take those sums and we can actually drag this all the way across to get the grand total as well, right? Once we have that, what we're going to do next is another important component of our chi-square test, which is calculating our expected values. These expected values are representing what we expect our data to look like under our null hypothesis. And in this case, our null hypothesis is that there's no difference in behavior between the predator absent and the predator present conditions. How we're going to calculate these expected values is by multiplying the total for each column for each behavior by the total predator absent or the total predator present. Both of those values should be equal again, right? And then we're going to divide by the total for each column, right? So we can kind of do that same process for the swimming behavior as well. So again, we're just multiplying the total for each column for the swimming observed data by the total number of observations total, right? And then dividing by the total sum of observations across both the predator absent and predator present conditions. And we would do the last kind of final calculation here as our feeding column total for the observed data again, multiplied by the total for the row. Either of those rows again would work fine. And then we want to divide by the total across both rows. So what this is now representing is what we expect our data to look like for this null hypothesis, given that the predator is not absent, right? And again, because under this null hypothesis, we don't expect any difference in behavior between the predator absent and present conditions, the expected values for the predator absent condition and the predator present condition are actually going to be the same. So we can just copy and paste those over. We want to make sure we're pasting just the values right. And that is now our expected data table filled out appropriately. How we're actually going to do the chi-square test is by using the chi-square dot test function in Excel. And we're just going to select two series of data. The first of these is going to be our observed data, or the actual range as it's termed in Excel. So we're going to select the 6 columns there that are relevant, right? Remember, it's just the raw count, total sum count data, not the sums for each column. And then we're going to select the second data series, which is going to represent our expected range, or again, that distribution of data we would expect under a null hypothesis of both of these conditions not having any impact on behavior. So once we do that, we have our associated chi-square value, where this is actually a p-value, right? We would interpret this in the same way that we interpreted our p-values last week. So again, we're just looking for any p-values which are less than or equal to 0.05. In this case, obviously, much, much less than 0.05. And so a very, very significant comparison we're looking at. And I mean, looking across it, it's kind of obvious here, right? For our predator absent observed data, we have the vast majority of these individuals performing breathing for most of these trials, versus for a predator present condition, we have a lot more of these individuals kind of participating in feeding behavior instead. So, very, very significant comparison that's going on there. That's pretty much it for doing the chi-square test calculation. You would be using this kind of value, this p-value here, to kind of note which comparisons are significant in your Gradescope homework, and then kind of focus in on those significant comparisons, right? Again, and this is kind of evaluating support for whether or not we actually see difference between these two different conditions. So in this case, we would say that there is a strongly supported difference in the kind of impact of predator presence on the amount of or proportion of time that mosquitoes spend performing each of these behaviors, basically. Okay, so let's move on from our chi-square tests using the mosquito data to now working with our fish data a little bit. So this is how our fish ID or our fish data should look like, hopefully. We have our activity in one column and we have our weight in another column. The first thing we're going to do is generate two histograms for each of these separate data series. And so this is fairly straightforward. We're just going to, there's no calculation of averages or standard deviations or anything like that this week. We're just going to highlight this, the relevant cells. And then this time we're inserting a histogram, right? So that's this little selection here under that insert kind of tab again. So we're selecting our histogram, and this is kind of what pops up initially. You can see all those different elements that are usually available for our plots, right? We can modify our chart titles, we can add axes labels in the same way that we've done in the past. Give me one second. Yeah, in the same way that we've done in the past, right? Just by selecting, by selecting our chart, going to chart design, and then adding our primary horizontal, our primary vertical, and then we can give those appropriate titles, right? Both the main chart title as well as the individual axis titles as well. Something that's unique about our histograms is that an additional kind of modification we can do is play around with how many of these separate bins are included. So I guess backing up a little bit, what a histogram basically represents is on our x-axis here, we have the kind of bins that are representing the different possible values our activities can take, right? This is most commonly used for displaying continuous data that can occur over a range of possible values. And so this kind of binning way of displaying data makes sense for these kind of continuous variables oftentimes, especially when you're thinking about like really, really um, large and like multifaceted data sets as well. So one of the things we're going to want to play around with a little bit is just seeing if we can change how many of these different bins are included within the histogram. So we can start, first of all, there's six total kind of data points that are going into this, right? And so if we expand this all the way out to six, right, you can see that I'm modifying the number of bins by selecting to format the data series, right? And then under this bins kind of under this bins kind of selector here, I'm selecting number of bins, and then I'm going to bump that all the way up to six. So once I have this, all that it's basically doing is it's dividing up the range between the minimum and the maximum of the data series into six equally sized bins, right? So the minimum here obviously being 61 and the maximum being 167. It divides that range between the value of 61 and 167 into six equally sized bins and then places each of these kind of values in the actual data series into one of those bins. So what this is saying here is that we have two of these values that are falling into the first bin, right, between approximately 61 and 78.6 repeating. That would be our 61 and our 69 data points, right? We then have our second bin, which is capturing from 78.6 all the way up to 96.3. And we have again two values within that bin. That would be our 88 and our 90 values respectively. And then for our two largest bins here, right, from 131 to 149 and 149 all the way up to 167, we have one value each, that being the 136 for the lower bin here, and then a 167 for the higher bin. So this is probably too many bins for visualizing the type of data that we have. And so we can bump this down a little bit until it starts to make a little bit more sense. I would say this is probably something that's appropriate and okay to go with. We have now four bins that are kind of like spread across this range. Again, you can see the minimum 61 and the maximum being 167. And our y-axis on this is always just going to be count or frequency, right? It's the number of observations that lie within each of the bins. So there's not a whole lot of modification that's necessary for these. Basically, just play around with the bins until you arrive at a bin number that you're happy with. Add your usual main chart titles and your axis titles, and then these should be good to go. No need for any standard error bars or anything like that. And we're going to do the same thing for our weight data as well. So we're going to go back to insert. We're going to insert our histogram, and you can see that this is formatted in a very, very similar way, right? We can do the same thing in terms of like playing around with the number of bins that are present, selecting number of bins, bumping up the four to see what it looks like. I would say four is actually pretty good, captures a pretty good amount of variation in that data set here. And you can see it's equally dividing between 0.479, which is our minimum value, and then 1.324, which is that maximum value, right? So as we increase the number of bins, the size of each bin is going to get smaller, but all the bins are always the same kind of the same size for a given bin number. So if we have four bins, all of these four bins capture the same amount of variation in that data set, right? Or the same range in the continuous variable. They obviously have like different counts because we have different kind of numbers of observations in each of these different bins. But this is something that we can play around with. We can bump this up to 5, we can take it down to 3 potentially. Lots of possible options here. And we would do the same thing here in terms of modifying the chart title. We would add the axis title and the horizontal and the vertical x-axis title. Horizontal and vertical axis title in the same way that we've done in the past. And then these should be good to submit afterwards. Or again, just going to use them as a source of interpretation to give you an idea of what the distribution of our data set looks like. These are, again, most commonly used when we have these continuous types of variables, right? They allow us to visualize distributions really, really easily. So the last thing we're going to do is we are going to generate a scatter plot, which has both of these variables kind of displayed at the same time. So what a scatter plot is you'll have one of these variables be represented on the x-axis and the other be represented on the y-axis, right? And so each x-axis value is paired with the y-axis value, and then that'll let you kind of visualize what the relationship between your x-axis variable and your y-axis variable looks like. So to get our scatter plot, we're just going to select both of the columns here, right? Both the weight and the activity data. We're going to go to XY scatter and select that first option there. So here is our nice scatter plot. You can see based off of the data range, right, from 0 to 1.4 is obviously our weight data. So we have our weight data on our x-axis, and then from 0 to 180 represents our activity data. So X is weight, Y is activity. We can add the same usual kind of axis labels that we would. Um, so we're going to make sure we have our titles, right? And you would label this weight in grams or weight parentheses G, and then activity or total crossings, right? For your vertical axis title. Your chart title for the main chart can probably be something like relationship between weight and activity, or I guess mass might be better. Gambusia. Nice. And the last thing we're going to worry about with this is adding in a trend line. So these are oftentimes things you'll see with scatter plots is people like to have trend lines on these scatter plots, right? So we can do that fairly easily by, again, going to the chart design kind of tab, looking at our trend line options, and we just want a linear trend line, right? We're not going to worry about anything like correlation coefficients or slopes or intercepts. We're just going to want to display what that trend line looks like. Basically, if it is pointing to the right upward, so if the right end of the trend line is greater than is higher basically than the left end of the trend line, then there's a positive relationship, which seems to be the case here, right? The opposite would be true. Sorry, if the opposite were true, this would be like a negative relationship. And now these are pretty much ready to submit. Again, you would use these to kind of help with your interpretation of the data set and search for any of these associations between your variables, right? You would, of course, modify your x-axis titles and your y-axis titles to make sure there's something that's appropriate. But yeah, as usual, if any of you guys have questions about any of the things we talked about today or in this tutorial, feel free to kind of reach out and I'd be more than happy to help out either in through email or in person during office hours as well.